Ever wondered why tossing a coin 100, 1,000, or even 1,000,000 times always seems to lead to a 50-50 split between heads and tails? This intriguing phenomenon is no magic trick, but rather a manifestation of a fundamental principle in probability theory and statistics known as the law of large numbers. In the simplest of terms, the law of large numbers states that as we increase the number of times we run an experiment, the average result gets closer and closer to the expected value. Imagine flipping a coin. It's a random event. But repeat it enough times and you'll find that the average results start to hover around the actual expected value. That 50-50 split we mentioned earlier. Breaking it down further, there are two main versions of this law, the weak law and the strong law of large numbers. The weak law tells us that as the sample size balloons, the probability that the absolute difference between the sample mean and the population mean is less than a specified value approaches 1. In other words, the average of a large number of trials will almost certainly be close to the actual population mean. The strong law, on the other hand, is a bit more forceful. It states that the sample mean will converge to the population mean almost surely, meaning it will eventually get closer and closer to the population mean and stay there. So how does this law find application in the real world? Well, it has a multitude of uses. Firstly, it aids in the estimation of population parameters. With a large enough sample size, we can use the sample mean to accurately estimate the population mean. Secondly, it's useful in testing statistical hypotheses. It can help determine whether the sample mean is likely to have come from a population with a certain mean. Thirdly, it's a vital tool in understanding the long-term behavior of random experiments, even if individual outcomes are unpredictable. Finally, it's a key component in creating Monte Carlo simulations, a computational technique that uses repeated random sampling to approximate complex problems. In conclusion, the law of large numbers is far more than just a theoretical concept. It's a powerful tool in the world of statistics, used in a wide array of applications, and helps us make sense of and predict random phenomena.